going to learn how to divide with exponents today. We, in our last video, learned about multiplying situations with exponents. And so today, we're going to learn how to divide. But first, let's review these two rules that we learned in our last lesson, which was that if I multiply with like bases, x to the third times x to the eighth, I add the 3 and the 8, and this is x to the 11th. Now, if I have a power to a power, like x to the third, and then there's a power on the outside like that, then I multiply these two. So this is x to the 15th. Those are the two main rules we worked with in our last lesson. But here's our new rule, and it involves dividing. Now let's think. If I add the exponents when I multiply, I'm going to subtract them when I divide. So my rule says that x to the m divided by, we usually use a fraction bar for divide, divided by x to the n is x to the m minus n, top minus bottom, okay? So a real easy example is if I had x to the 14th over x to the 9th, that would be 14 minus 9 is 5, so this would be x to the 5th. Okay, a real basic example of how that rule works. Now, you know that there's going to be more to it than that, so let's look at a couple examples here. Let's say on this first example that I have k to the 7th, m to the 10th p over k to the 5th, m to the 3rd p. Well, this problem really isn't that hard. 7 minus 5 is 2, so I'm going to have a k to the 2nd. 10 minus 3 is 7, so I'm going to have an m to the 7th. Now, how about here? Well, we learned that if there's no exponent, then the exponent is 1, and 1 minus 1 is 0. So what do I put here? I don't put p to the 0. Well, let me refresh your memory on something. Any number divided by itself, like 13 divided by 13, is 1. So this thing over itself just cancels out. It turns into a 1 and goes away. And that leads us to another rule. Anything to the 0 power, m to the 0 power is 1. Anything. 117 to the 0 power is 1. Some big ugly mess where you've got all kinds of stuff going on in here. Whatever that is. You know, cubed, z squared. If there's a 0 out here like that, it's 1. Okay, now the 0 has to be out here to turn all of that into 1. If one of these on the inside is 0, that's not the case. All right. So what about this situation? And this is going to lead us into negative exponents. What if I have n to the 5th over n to the 7th? Well, if I subtract top minus bottom, 5 minus 7 is negative 2. So negative 2. Well, what do I suppose I could say n to the negative 2, but where is that n to the 2nd power? Is it on the top or the bottom? Well, look at what this thing means. N to the 5th means this. N to the 7th means this. And based on what we just learned up here, all of these turn into 1s. And so my n to the 2nd is in the bottom. And that, my friends, is the rule for negative exponents. N to the negative 2 is the same thing as 1 over n to the 2nd. Here's the rule. A to the negative m equals 1 over a to the positive m. That's the first part of that rule. So in other words, you just move it to the bottom. Okay, you move this to the bottom and you change the power to a positive. The second part of that rule says if I have it in the bottom, like this, a to the 1 over a to the negative m, I just move it to the top and it becomes positive. It's now a to the m over 1. All right, so 2 quick examples and then we're done. You're going to be asked to simplify again. And let's say on our first example that we have 5r to the negative third t to the fourth over negative 20 r to the second t to the seventh u to the negative fifth. Well, first, let's simplify this 5 over negative 20. All right, that simplifies to negative 1 over 4, or I guess I could say positive 1 over negative 4. It doesn't matter so long as the negative is only in one place. Now look at this. Here's an r to the negative third, which needs to be moved to the bottom. So I'm going to have r to the third. Sorry about the bell. I'm trying to squeeze this video in when I have time. Times r to the second, like that. So we just moved this r to the negative third down here. Let's keep going. Here's another thing that sticks out. This u to the negative fifth, it goes to the top. And here, t to the fourth over t to the seventh, well, 4 minus 7 is negative 3. So that is in the bottom, like this. T to the negative 3 is 1 over t to the third, so it goes in the bottom. Okay? Now, we're basically done on this problem. Here I can add these exponents. 3 plus 2 is 5. So I'm going to have 1 u to the fifth over negative 4 r to the fifth t to the third, and that would be my final answer there. All right, one more problem. Let's say that I have inside 2a squared b to the negative third over 10a to the negative third b, and the whole thing is to the second power. Well, what I would do here is I would clean up the inside first. So this second power means I've got to deal with all of this. If it would have been a 0, we would have loved it, just said the answer is 1. So inside here, 2/10, all right, this turns into 1/5. 2/10 reduces to 1/5. The a to the negative third moves to the top, so now I have a squared times a to the third. The b to the negative third moves to the bottom, so now I have b to the third times b. We'll deal with this second power in a minute. So this is 2 plus 3 is 5, so this is 1a to the fifth over 5b to the, remember, this is 3 plus 1 if there's no power, to the fourth. Now we can worry about raising this thing to the second power. And it's pretty easy. This second power goes to all of these. 1 to the second is 1. Power to a power, this is a to the 10th. All over 5 to the second is 25. And then on the b, power to a power, 4 times 2 is 8. And we have b to the 8th. And that problem is complete. And hopefully that gives you a good understanding of how to divide situations where there's exponents. And we're going to stop there for today.